Today we are going to be looking at number properties, and the first one is the commutative property. And it says that we could either add, when we're adding or when we're multiplying, we can switch the order of the numbers. We can switch the order of the numbers. So let me show you how it works. If I took two numbers, like let's say 2 and 3, and added them together, I would get the same answer if I switched the order. If I put 3 first, then the 2. They still both give me the same value of 5. And it works with multiplication as well. See, I could take the number, let's say 50, and multiply it by 2, and I'd get 100. Well, if I go ahead and switch the order, and I put the 2 first, so this time the 2 first, then the 50, it gives me the same exact value. So that's the commutative property of either addition or multiplication. The associative property also works with addition or multiplication. It only works with these two operations. And it says that we can switch the grouping symbols. Or even just add grouping symbols. So either way, and you'll see some examples of both. So we can change these grouping symbols around. We'll still get the same answer. So let's take a look at a problem here. Let's say we had three numbers, 2 plus 1 plus 3. See, I could add the 2 and the 1 first, and that gives me 3. 3 plus 3 gives me 6. So I get that answer. Well, I can go ahead and take the same numbers. Again, it has to stay the same order, though. If it changed order, then it would be the commutative property. To be the associative property, it needs to have the same order. But the grouping symbols either need to be added or they need to be switched around different numbers. You see, I can add the 1 and the 3 first and get 4. 4 plus 2 gives me that same answer of 6. So either way I do it, I still get the same number. It works with multiplication. See, if I took 2 times by 3 times by 4, and let's say we multiplied the 2 and the 3 first, I could take the same numbers, again, keep the same order, and then multiply the 3 and the 4 first, so that you're multiplying different numbers before the other. So 6 times 4 makes 24. That's what I get when I use order of operation on this side. Over on this side, I get 2 times by 12, which is also 24. So you can see how the numbers agree. So that means it works. The distributive property, well, the official name is the distributive property of multiplication over addition. So let's see how it works. And so let's say I had a 3 times by 2 plus 4. So typically you'd do order of operation. You'd add and then multiply. Well, if I do that, here I would have 6 times by 3, which makes 18. Well, I can get the same answer if I use this distributive property. It says that we're going to take the 3 and multiply it by the 2. So we'll start with that, 3 times 2. And I can take this 3 and multiply it by the 4. And so I have to add 3 times by 4. And you see how 3 times by 2 makes 6. And 3 times by 4 makes 12, and those add to make 18. The same number we get when we multiply 3 and 6. So that's the distributive property. Well, taking a look at another idea, it's called a counterexample. Counterexample disproves a statement. So if we want to disprove, so again, this is a way to prove something, but we're going to use a counterexample to disprove what we don't want to say is true. So we're going to disprove a statement. So sometimes when we want to prove something, we kind of work backwards. Kind of like when we solve an equation, we work backwards to solve it. Well, a counterexample kind of works backwards in a way. We're trying to disprove something that we know is false to try to prove that something's true. So for instance, if I want to say that a certain month has under 30 days, I might use this as a way to prove it. So if I use a counterexample, I would say, well, no month has fewer than 30 days. Well, I can give a counterexample. February. February has 28 or 29 days. So there is an example, a counterexample that shows that this statement is false. So it disproves, it makes it false. And another one would be like a statement saying the commutative property is true for division. So this is a great way to prove that a property doesn't work for division or subtraction. See, I could do this. I could say, let's say 3 divided by 6 divided by 2. And so you see, if I use the commutative property, actually, instead of having 3 numbers, let's just change that to 2. Say 3 divided by 6 would have to equal 6 divided by 3. So you see, now I'm going to show you that the commutative property does not work with division. See, if I did this, commutative property says switch the order, and I have division in between. 3 divided by 6 makes 1/2, where 6 divided by 3 gives me 2. So it gives me a different answer. So those don't equal, so I've proven that the commutative property does not work for division. And so that's what a counterexample is for. It's to prove something, but kind of going at a backdoor approach. Well, the next few problems are going to ask us about naming some properties. So using these ideas about properties that we talked about. And looking at this first one here, it shows some numbers, and we have to figure out which property it is. Well, look at the order first. 4, 1, 2, 4, 2, 1. It looks like the associative property, but the 2 and the 1 are still inside the parentheses. It did not change. So what did change, though, is the order. And so since order changed. And so if you see order changing, that means we're dealing with the commutative property. And the commutative property is, in this case, it's of multiplication. So I'll put a little time sign there for that. Looking at our next one down below, it's 6, 8, 2, 6, 8, 2. So order did not change in this case, but the parentheses changed. Notice how the parentheses are around the 8 and the 2. Here they're the 6 and the 8. So when we see grouping symbol change, that tells us that now we're dealing with the associative property. The associative property, kind of like an association, is a group of people. Well, the associative property, in this case of multiplication, is a grouping symbol around different values. Look at our next one down below. We've got 5, 2, and x. Here we have 2 plus x times by 5. This is actually order changing. Notice how the 5 moved over to the right-hand side on this side here. So order changed. Whenever you see order changing, that tells us that we're using that commutative property. Commutative property, in this case, it's of multiplication, because we're multiplying the 5 by this sum, this 2 plus x, and that's what switched. Look at our next one here. Here we see grouping symbols, here we don't, but it's not the associative. Notice how we took 3 and multiplied it by x right here. And then we took the 3 and multiplied it by 2 right here. This is called the distributive property. And over here on this next one, here we have 15 minus 3x. And a lot of people want to say the associative property because they see some parentheses in the problem, but it's not. It's the same property. The difference is that they multiplied the numbers out. See, this makes positive 15. And when I multiply negative 3 times x, that makes a negative 3x. The same thing we get right over here. So this is also the distributive property. Well, one more here. Here we have 2 plus 8 plus 4, 2 plus 8 plus 4. So order does not change, but what's changing? See, it's not the distributive property because we didn't distribute anything. There's no number that got multiplied over this. So what we actually did here is it's a grouping change. Now, even though you don't see grouping symbols on the left-hand side, what we would do is do order of operation, which says we do the stuff on the left-hand side, work our way to the right. Well, here we're saying, well, I want you to work from the right to the left, so that's a grouping change. So this is the associative property. If you change the parentheses, you change the way you're going to end up adding it, that's that associative property. And so that means that we've got the associative property of addition. These are the types of problems you'll see on tonight's homework. Good luck.